Hello, my name is Dr. James Parham with Trude Environmental Solutions, and my co-author on this presentation is Glenn Higashi with the Hawaii Division of Aquatic Resources. And we'll be talking today about the impacts of water releases on in-stream habitat and biota in the Waimea River, Kauai, using high-definition stream and fish survey techniques. As an outline for this presentation, we'll cover the high-definition stream surveys, or HDSS, high-definition fish surveys, or HDFS, and use examples of these two techniques from the Waimea River project. First off, what is the high-definition stream survey? The high-definition stream survey is a relatively simple field method that allows water quantity, water quality, habitat, outreach, stream corridor assessment, and infrastructure surveys to be completed in a single pass, with all of the data able to be integrated into an overall planning framework. High-definition stream survey provides high-quality data, which is at the heart of integrated water resource management, and it locates and documents all the different issues in a stream. HDSS is fast. For example, we surveyed Iao Stream on Maui from the ocean to the park, approximately 4.7 miles, in about 10 hours, and that provided a continuous habitat and fish survey of that whole section. The HD stream surveys make it easy to document the quality of in-stream habitat. This is an example from Manoa Stream on Oahu. You can see riffle runs and pools as you look forward. You can see the water depth and substrate as you look down, and easily assess stream bank and riparian conditions off to both and right and left bank. Additionally, high-definition stream surveys make it easy to document many other issues in the streams, and I'll highlight just a few of those here. Here is Pololo Stream flowing into Manoa. You can document the change in habitat as well as water quality and water temperature. Here is an example of stream bank clearing. Many times, local landowners will clear the stream bank for a better view or for other perceived benefits, but quickly the stream will begin to erode the bank and cause additional problems. A big issue is stream diversions. We can clearly see the in-stream conditions below, at, and above diversions. In this example, a diversion removes 100% of the water, leaving a stream dry below it while beautifully flowing above it. Transitioning to the high-definition fish surveys, these surveys are coordinated with the high-definition stream survey and allows us a rapid, low-impact documentation of fish and their habitat use. High-definition fish surveys are underwater video that is geo-referenced, allowing you to do very quick point quadrat surveys in a wide range of habitats. They provide species information, the type, number, size, sex, as well as habitat information such as the habitat type, substrate, or depth at which animals are found. And here's an example of the coordinated surveys. Here's the above water stream survey showing habitat. And now the fish surveys will be able to show what's under the water. You can see in this shot the video camera is being placed into the water, and you can immediately see a lot of fish. And here's the above water view showing the small camera going into the water. Remember, these are geo-referenced, so we know how long this image is taken, where it's taken, and we can collect all kinds of information on the size, the species of fish observed, the habitat they're found in. And as you can see, the resolution of the video is extremely high and allows us to get very detailed information about the species and their habitat use. And now let's transition back to our original project report. This is showing a combined stream survey and fish survey used below a diversion on Kauai to assess the impacts of different flows. The primary objectives of the project included three things: document the species present in their habitats, document the in-stream habitat at diverted and restored flows, and then estimate the change in suitable habitat as a result of the increased flow. The project was located on the Waimea River on Kauai. The diversions, shown here, removed substantial amount of water, and we surveyed 2.7 kilometers downstream of these diversions at multiple different flow rates. We used the HDSS and HDFS methods that we described earlier, and we'll move right to the results on how they applied to this in-stream flow project. So here are the results of the fish surveys. Typically, you'd see a table like this showing the species, their abundance, size, classes, and sex, or other information. And we were easily able to achieve this using the high-definition fish surveys. But in addition to having a data table, we also have very clear video showing these animals underwater. And let's see some examples. One of the great things is that you can actually see the animals. The fish high in the water column here are the green swordtails, and then the oopu down towards the bottom is oopu nakea, a native stream fish. The beauty of this type of video is, one, you can see the water depth, you can see the substrate, you can see the animals and their size, but you can also take the time to count them. There are 5 oopu nakea in this screen. Although you may not be able to see them all right now, they're very clear when you project them on a large screen. Here's a Tahitian prawn, also found in this area. You can see the type of habitat it lives in, here next to a large boulder. And then you could survey down in hard areas like under cascades. And there is oopu nopili, another native stream fish living on the rocks in swift water. So this highlights the ability to see these things. Here's an example of our second goal, to determine the changes in habitat resulting from the increased stream flow. On the left is diverted flow with about 2 million gallons a day. You can see the exposed rocks. And then on the right, you see the restored flow with approximately 7.7 million gallons a day. And now much of the stream width is filled, and there's a lot more water and many more rocks are underneath the surface. So we can take our time to quantify that, exactly what it means, and for each meter of the stream through the survey section. Here's an example. This is the diverted flow. You see the little grasses sticking up in front of us here, and walking around it. It's pretty much dry to the left, and there's some stream to the right. Here's that same area with the clump of grasses sticking up in front of us, and there's flow going around both sides, and there's much deeper water and much swifter water. Again, here's an example with a large rock underwater, and then, or exposed and then underwater. And here's that flow comparison. As we walk through this segment, again, these were done on different days, and then these pictures were joined. We can see that exact spot, and you can really get an idea of how much more habitat there is in these sections and what that habitat actually looks like. This is very difficult to achieve from transects alone. So this method is a great method to quantify the change over broad areas. So what do we do with the habitat classification and all the species observations? Well, in this case, we looked at the suitability for the native nopili. This fish prefers swift water through cascades and riffles, and avoids slow, non-flowing areas. So we're able to set up a criteria like this from poor to good and go through and reclassify all of the video based on this suitability criteria. What does that look like? Well, here's an example of the upper reach of this segment. At diverted flow, there was some good habitat, and we did see some animals in here. But at the fully restored flow in the middle, much of the area below this diversion was highly suitable for this species. And then because these are one-to-one comparisons, we're able to look at the percent change for the amount of habitat throughout these segments. Okay, in the left-hand graph, the blue bars are diverted flow, the red bars are partial return, and the green bars are the full return. And you can see a shift from unsuitable habitat on the left, where it's more frequent at diverted flow, to good habitat on the right here, where it's much more common at the return flow. Those values can then be plotted to look at this percent suitable habitat and its return, and to choose an area where we maximize the rate of return. And so in this example, about 6.5 million gallons a day were recommended to maximize habitat for this species. Overall, we could say that the project strengths for this was that we completed full fish and habitat surveys over 2.6 kilometers. It was a fast turnaround project from hitting the field to a report in less than a month. It was a low-cost project since it was done really quickly with only 2 people in the field and 2 people for the analysis. And all of the source documentation, all of these videos are available for review if someone would dispute the findings. Overall, these HDSS and HDFS projects provide fast, accurate, virtual stream walks for our surveys. You can come back and see what the conditions were at a later time. It's easy to develop all kinds of GIS habitat layers for bank condition, depth, habitat type, etc., that allow us to be used in many projects from in-stream flow to infrastructure or water quality projects. And it's fully reviewable, so you can assess changes, either good or bad, over time. In summary, the HDSS and HDFS approach is very effective. The technology exists. It's been proved to work on multiple projects across Hawaii and the continental United States. There's data management processes in place to do bank condition analysis, habitat mapping, fish surveys, habitat suitability modeling, hotspot prioritization, barrier assessment, project impact, mitigation planning, and in-stream flow allocations. Overall, the method allows us to collect high-quality data faster than traditional methods and at a lower cost, giving us a better overall project. Thank you, and if you have any questions, please feel free to contact us.